For ages, folks have wondered if there's life on other planets. Now, with the James Webb Space Telescope, JWST, the most awesome telescope ever, we can actually check it out. Scientists spotted some weird stuff coming from Proxima b, a planet in our closest star system, Proxima Centauri, just over 4 light-years away. These artificial lights have got experts scratching their heads. What are they? Could they mean there's smart life there? We only know about life on Earth, and ever since we started thinking, we've wondered if we're alone. Back in 1984, some American astronomers, Jill Tarter and Thomas Pearson, kicked off the SETI project to look for alien signals. The idea is to pick up radio waves from space since they can travel super far. They used the Allen Telescope Array in California, which has 42 radio telescopes. So far, though, no confirmed alien signals. With the JWST up and running, we're doing way more study of planets around distant stars. It's the biggest telescope out there, hanging out 1 million miles from Earth with super-sensitive gadgets. It's bound to find some cool stuff. 20 years ago, we didn't know about any planets outside our solar system. Now, NASA says we've found over 4,000. There could be trillions out there. One of the first clues about life could be plant life. When the Galileo spacecraft was headed to Jupiter, it looked back at Earth and saw a clear sign of plants, the vegetation red edge, VRE. It's a combo of red and infrared light that plants reflect. A planet covered in jungles would send out a strong VRE signal. The JWST will measure the VRE of Earth-like planets in that habitable zone around stars. That could tell us if there's life in their atmospheres. When sunlight passes through a planet's air, the JWST can detect missing colors. Atoms and molecules absorb certain colors, making a unique fingerprint the JWST can recognize. This could tell us what's in the atmosphere and if life's possible. Life could be on Earth-sized planets with air like ours, rich in oxygen, nitrogen, and carbon dioxide. Another way to check for alien life is to look for stuff that shouldn't be there. For example, chlorofluorocarbons, CFCs, used in fridges and cleaners, would probably catch an alien's eye if they were watching Earth. If the JWST finds CFCs on a planet, that's a big hint of civilization. But life on other planets might be weird. Even some Earth creatures, like extremophiles, which live in crazy environments, seem alien. These guys, mostly bacteria, can handle extreme heat, up to 250 degrees Fahrenheit, or strong acids. Since Earth-like planets are more likely to have life than those with extreme conditions, that's probably where we should start looking. The best candidates might have temperatures that allow liquid water and orbit stable stars. Our Sun is a yellow G-type star. These aren't super common and don't last as long. However, we're more likely to study planets around red dwarf stars, which are more common but dimmer and cooler than our Sun. These stars live longer, giving life time to start and get complex. The JWST's first mission will be to study the TRAPPIST-1 system, about 40 light-years away. It's got 7 Earth-sized, rocky planets orbiting a calm red dwarf star. 3 of them are in the habitable zone and might have liquid water. Even though the star is smaller and colder than our Sun, its planets get about the same amount of light because they're so close. If we want to see city lights outside our solar system, Proxima Centauri is our best bet. It's a red dwarf star, 4.25 light-years from us. Proxima is way dimmer than the Sun, about 600 times, so a planet has to be 20 times closer to it than Earth is to the Sun to have liquid water. In 2016, astronomers found a planet called Proxima b in this habitable zone. It's about 1.3 times the size of Earth. It orbits Proxima Centauri, but it might not have air or life. Because it's so close, only 4.66 million miles, it gets blasted by strong solar winds that could strip away its atmosphere. Still, it gets enough sunlight for Earth-like temperatures and liquid water. Because it's so close, Proxima b is probably tidally locked, meaning one side always faces the star, like our moon facing Earth. Proxima Centauri is about 18% of the Sun's mass and doesn't shine very brightly. The planet might seem red-hot since it's so close, only 5% of the Earth-Sun distance. Liquid water could exist if Proxima b has an atmosphere to trap heat. Since it only gets 65% of the energy Earth gets, it's not ideal for life. It's probably tidally locked, with one side always facing the star, making huge temperature differences. It also gets 100 times more high-energy radiation than Earth, as well as high-energy particles from star flare-ups. Without a strong magnetic field, life might be tough. Some things could make Proxima b more livable. But we don't know anything about Proxima b's volcanic activity or magnetic field strength. We can't even guess whether or not the planet has an atmosphere. We are eager to know if Proxima b harbors a sophisticated civilization. Who knows? Maybe they have solar panels on the day side to make electricity and light up the dark side. Now, everyone's racing to see if Proxima b crosses in front of its star from our point of view. If it does, we can figure out its size and mass, which would help us know if it's rocky. During a transit, starlight can pass through the planet's atmosphere, revealing what's in it. Sadly, there's only a 1.5% chance Proxima b's orbit lines up for us to see a transit. Plus, the star's flares make it hard to watch. Astronomer David Kipping says the star is tricky to work with. Heat from the star makes the planet absorb sunlight and send it back as infrared radiation. But planets and stars give off different kinds of infrared. This is where the JWST comes in handy. It's built to steady infrared light, so it's perfect for spotting Proxima b's atmosphere. Theoretically, the JWST could spot city lights on Proxima b's dark side, even if they're faint. It could see them if they're in a very narrow frequency range compared to the star's light. If Proxima b's day side is covered in solar panels and its night side glows steadily, we might see the difference through something called light curve analysis. As the planet turns, the changes in brightness could point to a non-natural energy source. If these lights are real, they're not ours. This is super exciting. If we confirm them, it could be the first proof of a smart alien civilization. To tell real light from fake, scientists look at a planet's light curve to see how its brightness changes. If the night side's brightness doesn't match what should be reflected from starlight, it could mean technology is at work. If the day side reflects sunlight from solar panels and the night side stays bright, the JWST could spot this difference. Artificial light has a unique spectral signature, with wavelengths that nature doesn't usually produce. Street lights on Earth, for instance, shine in certain colors of visible or infrared light. If Proxima b's night side is always bright and doesn't change with the planet's rotation, it could mean it's being lit. These lights could be keeping the dark side warm and livable, since it's tidally locked. This isn't just science fiction anymore, it's a real idea being tested with our latest telescopes. The idea of seeing alien cities from across the galaxy used to be a dream, but now it's getting real with telescopes like the JWST. When sunlight goes through a planet's atmosphere, the JWST can use spectroscopy to see what wavelengths are missing. Atoms and molecules absorb certain wavelengths, leaving a fingerprint that the JWST can recognize. This helps us figure out what's in the atmosphere and if life could be there. If there are Earth-sized planets with atmospheres like ours, mostly oxygen, nitrogen, and carbon dioxide, we could look for unusual stuff that might mean there's a civilization. For instance, if we saw chlorofluorocarbons, CFCs, used in old refrigerators, in the air, that would be a pretty good sign. But life on other planets might not be like what we're used to. Even some life on Earth, like extremophiles, creatures that can live in crazy conditions, seem alien. These guys, mostly bacteria, can survive in super hot temperatures, up to 250 degrees Fahrenheit, or strong acids. It might be best to start by focusing on planets that are more like Earth since they're more likely to support life than ones with extreme conditions. We're looking for planets with temps that allow liquid water and that orbit stable stars. Our Sun is a yellow G-type star. These aren't as common and don't last as long. However, there's a better chance of finding planets around red dwarf stars, stars that are smaller, cooler, and more common than the Sun. Because they live longer, there's more time for life to form and evolve. The JWST's first mission is checking out the TRAPPIST-1 system, about 40 light-years away. It's got 7 rocky, Earth-sized planets orbiting a calm red dwarf star. 3 of them are in the habitable zone and might have liquid water. Even though the star is smaller and colder than our Sun, its planets are so close that they get about the same amount of light as Earth does. Proxima Centauri is another good prospect for seeing city lights outside our solar system. It's a red dwarf star, 4.25 light-years away. It's way dimmer than our Sun, so a planet has to be much closer to get enough warmth for liquid water. In 2016, scientists found a planet called Proxima b in that zone. Proxima b might be a lifeless rock because it's so close to the star. The strong solar winds could have stripped away its atmosphere. Still, it gets enough sunlight for Earth-like temperatures. It's likely tidally locked, meaning one side always faces the star, just like our Moon. Proxima Centauri is only about 18% of the Sun's mass and doesn't shine very bright. Even though Proxima b is close, only 5% of the distance between Earth and the Sun, it might seem like a red-hot rock. Liquid water could still be there if it has an atmosphere to hold in the heat. The planet probably has a permanent day and night side, with huge temperature swings. It also gets blasted with 100 times more high-energy radiation than Earth. If it doesn't have a magnetic field, life might not have a great chance. Some think Proxima b could be livable under the right conditions. Models suggest that tidally locked planets can lose their atmospheres easily because gases freeze on the night side. Volcanic activity can replenish the atmosphere, and a strong magnetic field can protect it. We don't know if Proxima b has volcanoes or a magnetic field, so we can't say for sure if it has an atmosphere. But if it does, that likely means there are oceans, and that usually means there's life. So, we're eager to know if Proxima b has a civilization. Maybe they have solar panels all over the dayside to make electricity and light up the night side, making it warm enough to live there. People want to know if Proxima b crosses in front of its star, transits, from our view. If it does, we could figure out its size and mass, which would tell us if it's rocky. When a planet transits, starlight passes through its atmosphere, revealing what it's made of. However, there's only a 1.5% chance that Proxima b's orbit lines up for us to see a transit. Plus, the star's flares make it hard to observe. Astronomer David Kipping said the star is hard to work with. Heat from the star makes a rocky planet absorb sunlight and send it back as infrared radiation. But planets emit a different kind of infrared radiation compared to stars. That's where the JWST comes in. It's designed to study infrared light, making it perfect for spotting Proxima b's atmosphere. The JWST could even see city lights on the dark side if they're as faint as ours. If Proxima b's day side is covered in solar panels and its night side has a steady glow, we might be able to tell the difference using light curve analysis. As the planet turns, the changing brightness between the day and night sides could point to an artificial source of energy. If these lights truly are artificial, well, they're not ours. If confirmed, artificial lighting on Proxima b could be huge. It could mean an intelligent civilization. To tell natural light from artificial, scientists look at a planet's light curve. If the night side's brightness doesn't match what should be reflected from starlight, it could mean technology is in play. If Proxima b's day side reflects sunlight from solar panels and its night side stays consistently bright, the JWST could spot this imbalance. Artificial light has a different spectral signature. It emits wavelengths that aren't typically natural. For example, street lights on Earth shine in bands of visible or infrared light. If Proxima b's night side has constant brightness that doesn't change with the planet's rotation, it strongly suggests a society managing their environment. These lights could be keeping the dark side livable. This idea isn't science fiction, it's a real scientific theory being tested with modern instruments. The thought of seeing alien cities from across space was once a dream. With telescopes like the JWST, it's becoming a real possibility. Still, we need to be careful. Just seeing light doesn't mean there's intelligent life. We need to look deeper. Scientists have to rule out natural causes first. Could the light be from geothermal activity, weird stuff in the atmosphere, or rare mineral reflections? Everything natural must be crossed off the list before we say it's aliens. If we find clear artificial signals one day, it would be a game changer. It would mean we're not alone. Maybe 4 light years away, there's a civilization smart enough to use energy, build things, and light up their world. This would change everything about how we see life, technology, and our place in the universe.